Hello everyone, today we'll be discussing the pH levels, acids and alkalines, and then we'll also be discussing the natural pH indicators, universal indicators such as the red cabbage. So what makes the red cabbage very special is that it has anthocyanins, which is a pigment that makes its color purple or red color, and this pigment allows it to change colors according to the pH scale. However, in neutral form it is purple instead of green, but then when it goes up to the alkaline level, which is from 7 to around 14, it turns to bluish greenish color, and from 7 to 0, which is acids, turns into a reddish orangish color. So now, in order to start, we first need to get off with the safety gear. First we have the scientific gloves, which would disinfect your hands, and also some of these are very hurtful for your hands, which can make some skin damage. And also we should be careful while doing such experiments with sharp objects, and also blenders and acids, alkalines, etc. So we'll first start by cutting the red cabbage and putting it into the blender. In order to make a red cabbage solution, we just need to cut it, just cut the leaves. We won't require much leaves. Okay, I think this is enough. Now we'll be taking these leaves into our blender where there is water inside. This is made in order to create a solution which would allow the anthocyanin pigments to spread among the water. Now, this is enough. In order to start such experiments, we also need the face cover. So a face shield is required. Now, we will start with blending. Now, if you're unexperienced with such materials, you need guidance of an adult, because these are very sharp and dangerous objects. So now we'll be filtering the solution into this mug to give the best and efficient results. And I think this is enough. Now this is the filtrate, and this is our solution. We will start by the lemon solution. Now we can see that some of the purple pigment has just leaked into this, which causes a slight red color. Now we know that this is acidic with regards to the pH scale. The lemon is very acidic. Now let's see what happens if we mix these mixtures together. You can see that there is a red color, which indicates that it is about 2 to 3 pH in the pH scale, which is very acidic. Now this includes citric acid, which makes the lemon very acidic. Now let's move on to the vinegar. The vinegar is also very acidic, and it contains acetic acid, which is also around 2 to 3 on the pH scale. Now let's see what happens if you add it to water, which is neutral. Water stays purple because this is the natural color of the red cabbage, So it stays purple, but it does not indicate that's alkaline. However, this is purple because the pigmentation color is purple. Now let's go to the baking soda. The baking soda is very blue, as you can see right here, which indicates that it is an alkaline with a pH about 10. And now we'll go to the washing or cleaning solution. Now the cleaning solution is very, very dark because this is a strong alkaline, as you can see over here. It would range from about 10 to 14. Now you can see also that this water has been a little bit darker. This is because this is actually tap water, and tap water may contain other alkaline substances. Now we could also observe that this changed to a yellow color because this is a very, very strong alkaline. First it was green and then it turned to yellow because it's a very strong alkaline, and it also fights the color of the pigmentation in order to create its own color. Now this is a pH of 2, this is 2 to 3, this is a pH of 7 because this is neutral, this is a blue color which is the alkaline for the baking soda, and we also have finally the washing solution which is a yellow color. Now let's try to mix some solutions. We will try to mix these solutions right here. Let's see what will happen. See that it changed to green color because this is a very strong alkaline. It doesn't really affect as much. However, let's take this solution and this solution right here. You would see that it created some carbon dioxide reaction. Now, after it creates a carbon dioxide reaction, it turns into a normal color, which is almost a blue color because this is still a strong alkaline. Now this is a carbon dioxide gas because of the foam that occurs between the reactions. Now, finally, we would see that this is a neutral color, which is the water. And if you try to mix the water and this acidic solution, it will result in a reddish color because the water has a neutral substance, which doesn't really make a difference. Now let's try to mix these together. This is a very strong alkaline which is already mixed, and it still takes the yellow color. As you can see, it didn't change because this didn't really affect it because this is a very, very strong alkaline. Now let's try to mix it. Now this is a green color. Let's wait a little bit. You could see that it's starting to change to a yellow color gradually. It was dark and now it's changing gradually to a yellow color. Let's just wait for a moment right there. Right here. Now it's starting to change to a yellow color. It's trying to neutralize right now because this is a very alkaline solution and this is a very acidic solution. Now according to the pH scale, this is around 1 to 2. The lemon is very acidic, which is 1 to 2. And also, we have the vinegar, which was already mixed, which is about 3 to 4, 2 to 3. And now we have the strong alkaline solution, which is one of the strongest, is about 10 to 14, or even more than 14 because it takes its own color and it changes colors. This is the baking soda solution, turned to the blue color, which is around 10 to 12 on the pH scale. However, the other ones are very, very acidic, which can cause damage. So an example of these damage can be skin burns. That's why we use equipment such as this and this in order to stop skin burns or skin cancer. It can also cause many of these. And also alkalines can make your skin very rough and it can peel off the skin. So we can observe that the acids are very corrosive, while the alkalines can cause severe damage to your skin. So I advise everyone to use these safety measures when creating such experiments. And thank you.